Here we are at our special 5:30 session with Jan Marwan. I'm going to make the introduction really short because we don't have much time. He studied chemistry at the Technical University of Berlin. He's got a PhD from the University of Southampton. He's been a research scientist at the University of Quebec in Montreal. He's covered, in particular, palladium hydrogen systems, ethanol oxidation on nickel-based alloys. I know he's done a lot of other work too, but that's going to be some of the focus of what we're about to hear. So here's Jan Marwan, all the way from Germany.
Okay, thanks a lot. It's a pleasure really to be here, and thanks a lot, folks, to you to invite me here. And it's really, I really appreciate it to be here. Okay, ladies and gentlemen, I want to talk about the palladium hydrogen system. It's a really fascinating topic, and especially because palladium has got the outstanding issue to absorb a large quantity of hydrogen into the metal lattice. And I've been firstly touched by this when I came to Southampton in the year 2000. And there I carried out investigation on this research topic. For luck, I was put into this, and it really didn't let me go anymore. Well, in principle, that's why a fascinating project. We all remember this in March 89, the Ponsen-Fleischmann experiment. And the idea to take this advantage, to take palladium, the hydrogen insertion into palladium, to create a collision of deuterium and to raise the nuclear reaction. Well, that's in principle a dream of human beings to create this. Yeah? And we all know they failed. They failed due to the lack of reproducibility of that experiment. And the answer of that has not been given yet, quite yet, the understanding of that mechanism. Well, I don't want to give any answer to this because I don't know that. But what I found out in my studies is a quiet approach to this. And the approach has been, that's nice, thank you. The approach to this is that we make advantage of the use of the nanotechnology. So this is, we go now, let me come right at the beginning with a message across, telling you that we are able, with the use of the nanotechnology, the use of the nanostructured metal film, we were able to insert hydrogen very rapidly into palladium. Well, and to remove it from the bulk palladium metal film. So, and we were able to distinguish between the adsorption and the adsorption process. Well, to make it clear, the adsorption process is the diffusion of hydrogen right into the palladium bulk. And the adsorption is, well, the deformation of the hydrogen layer right onto the metal electrode surface. While we could make a distinction between both processes, and also not written here, we found out that there is a direct diffusion of hydrogen into the metal electrode surface, right without passing through the adsorb state. Now, I found that without turning I shouldn't turn right to the electrochemistry right at the beginning. I found it more convenient to explain you how we create this nanostructured metal film. We exploit here the physical properties of the liquid crystalline template structure. Right by electrochemical deposition of a metal salt dissolved within the aqueous domains of a liquid crystalline metal film, liquid crystalline phase, using a high surfactant, non-ionic surfactant in combination with water. So this is a surfactant molecule here. Right? Okay, right. That's a surfactant molecule consisting of a hydrophobic chain and the ethylene groups. So, and you can take control over the pore topology by changing the hydrophobic chain length and the number of ethylene groups. And we can obtain different liquid crystalline media depending on the temperature, depending on the surfactant to water ratio. Let's begin with a micellar phase. characterized by hydrocarbon chains packed inside and the hydrophilic group forming the surface surrounded by the aqueous media. Increasing the surfactant to water ratio, you obtain the two-dimensional hexagonal array, so it's characterized by cylinders of indefinite length and the cubic arrangement, the three-dimensional arrangement. And increasing further the surfactant to water ratio, you obtain the lamellar phase separated by B layers surrounded by the aqueous phase. That all you will summarized in the phase diagram, the hexagonal phase, cubic phase, and lamellar phase. So that's determined here by mainly by the hexagonal phase occupying the phase diagram to a large extent, from which then the metal deposition can occur. And that you're going to see here, the micellar rods hexagonally arranged and vertically oriented to a gold substrate, around which then here the metal salt is dissolved within the aqueous domains. Electroplating can be carried out around those micellar rods, after which then the surfactant can be removed just by washing, and you obtain the nanostructured metal film characterized by pores running continuously in a hexagonal array through the film. That's it. That's our nanostructured metal film. Another model can be seen here. Inspection of the pores will reveal 2-3 nanometers pore size diameter and wall thickness of the same dimension. Right. In reality, it shows like this. I mean, you cannot see those films. Yeah, that's for sure. It's a 200 meter, 300 nanometer thick film, and those porous structure you cannot see. You need to use TM, transmission electron microscopy, and it shows pores running through the film in a hexagonal arrangement here. Again, 2-3 nanometers. That's a hexagonal arrangement, cubic arrangement. Can you see that? Okay, right. And surface morphology. Well, I cannot see that. No. Okay, surface morphology can be envisaged by using a scanning electron microscope, and you will see should see a smooth surface by the deposition of platinum, that's platinum film, onto the nanostructured platinum film onto a vibrate gold electrode. So the same can be done for nanostructured palladium film, giving a TM, and that's a low angle X-ray diffractogram with a singular peak, giving clear evidence for a regular pore distribution over the whole surface. And from the Bragg diffraction, you can estimate a D-spacing, giving a pore distribution of the same dimension from consistent with those values obtained by TEM. Okay, so now we can turn to the electrochemistry. And the electrochemistry, what we usually use as cyclophotomic measurements, it's just to plot your current versus a potential applied. And it's just a usual tool to obtain some electrochemical features of your film, your electrode. Okay, so here we go anorically, and we see here two multimetries of our nanostructured film and the plain electrode, just a palladium wire. And going anorically, we see a formation of a surface oxide layer giving rise on the reverse cathodic scan to a well-defined stripping peak. So that's very large. It's very much larger than the plain electrode film, and that's due to the fact that we obtain here a porous nanostructured film. You wouldn't have that on a palladium wire. Yeah? So okay, we obtain here a high electrochemical surface area. And that's the cathodic scan. The nanostructured film in red reveals now very well resolved features. So I give now the attribution. That's here the adsorption peak, and that's now absorption peak, the alpha and the beta hydride phase. So if we want to study our absorption behavior, of course, then we turn to alpha, beta, maybe our gamma hydride phase. Let's leave it to alpha and beta hydride phase. And you will see for the plain palladium film that you cannot draw any distinction between adsorption and absorption peak. And nobody could do it before, Pons Fleischmann neither, yes? But here in those studies, we can do it, yeah? So, And well, that's the ordinary mechanism. If you take water, you discharge it, and you will obtain the adsorption of atomic water onto an electrode. That's a formal reaction from which then by electrochemical the electrochemical desorption occurs, and all the recommendation type reaction. These are two competitive processes. But okay, that's not the focus right now. Okay, the attribution between adsorption and absorption peak can be given by addition of crystal violet. Right. Okay, here I see something what doesn't work in PowerPoint. Anyway, we can see here two voltammetries. The one is without, let's put something in introduction. Normally you can, with the addition of a poison like crystal violet, which is an organic compound, you can knock out the hydrogen adsorption onto the palladium metal electrode completely. So this is what we use in our study. We have to make a distinction between absorption and adsorption behavior. And here we did this in our study. So we actually, we can see two voltammetries. That's without the addition of crystal violet. That's with the addition of crystal violet. And here you can see that this peak is completely knocked out, and we think that this peak is now attributable to the adsorption of hydrogen onto the palladium metal electrode. So we are now left with the remaining absorption behavior, and determined is this by the beta hydride phase. Okay. Now, if we then load, we want to give now in the next experiment a transition between the alpha and beta hydride phase. If we now in our next experiments, we load our hydrogen into palladium. That's the goal, yeah? You load your hydrogen or deuterium into palladium, and you see what's going to happen. So you load it into your the palladium metal electrode, and you oxidize it on the way back, anodically, and you obtain here a peak. That's attributable to the oxidation of absorbed hydrogen diffused in your bulk, and that's attributable to your adsorbed hydrogen, attributable to your hydrogen adhered to a metal electrode surface. So then you integrate this charge, make it converted to a hydrogen palladium ratio, and you will obtain this curve, very familiar curve. H palladium ratio to as a function of the potential. Now you can distinguish between the alpha and beta hydride phase, and using a nanostructured metal film, we obtain a very, very rapid transition between the alpha and the beta hydride phase. Right? Here at more cathodic than minus 0.7 volt, there is a drastic increase in the H palladium ratio. I think it's attributable to the double layer charge capacitance, but that goes too far to discuss it here. So, and now let's discuss in detail now the absorption behavior, yeah, the diffusion of hydrogen into bulk palladium, into palladium metal. So we take here the voltammetry, the black curve, where there's no coverage of any Poisson done. Here you can clearly distinguish the absorption behavior and the adsorption behavior, both distinguishable. Now you add subsequently crystal violet is an organic compound. You add it subsequently 0.5 millimolar, 1 millimolar, and you see there's some changes going on. Right? So we leave it just by that. We go to the next figure, and the same. Other experimental conditions in acidic solutions. Okay, we just did here deposited at submonolayer coverage of platinum. So one monolayer, one platinum atom on 10 palladium atoms, and 3 platinum atoms on 10 palladium atoms. Okay, but the first curve, the black curve, is also again the absorption behavior and the adsorption behavior, and there's no platinum coverage done. So, and you can see here in the insert that the adsorption behavior disappears subsequently. Okay, so we keep this in our mind. And now we focus clearly on this. We see, comparing the anodic and the cathodic wave, that the distance between both becomes smaller. Yeah? And we see that the width at half height gets also narrow, becomes smaller. Okay? But the mid-peak potential here remains unchanged. That indicates that the thermodynamics of that system, they don't change. Just what we can see here, that the kinetics change and they are significant enhanced. So what does that mean? It means I live really in a desert. It's so dry, yes? It doesn't matter. But okay, so it really means that, yeah, sun. I like that. I live in Salt Lake City. That's so nice. So it means, thank you, that if you cover your electrode, the palladium electrode, with an organic compound like crystal violet or submolecular coverage of platinum, you really can enhance, or let's say affect, the rate of hydrogen entry into your palladium metal electrode. And that means that your hydrogen diffusion is enhanced. Okay? And the other fact to be pointed out is that your adsorption behavior disappears. Your adsorption peak disappears, just disappears. Right. That means we must have removed the hydrogen layer blocking the surface. Okay, so in reviewing all the literature covering the material about the poisoning, on promoting the hydrogen absorption into the metal lattice, there is no clear consensus to be found on this. One literature proposes a model like this, one literature another model, okay. But no clear consensus. All authors have one thing in common. They proceed from the assumption that the adsorb state is a precursor and intermediate for the absorption of hydrogen. Okay, but now, here's my question. If that's true, and the adsorb state is an intermediate for the absorption of hydrogen, and the formation of adsorbed hydrogen from the adsorbed state is a chemical reaction, is driven by the change of the chemical potential, and is not driven by the applied potential. How come that this state is a precursor of this state if here is a change in the potential of 200 millivolt? Yeah, if you understand what I mean. This is impossible to claim that this state, adsorb state, is a precursor of this one. Okay, this is thermodynamically impossible because the system here is only kinetically enhanced. If you come up now with the idea to say, okay, there might be an adsorb state on the path to the hydrogen evolution, that's the hydrogen evolution, which could be an adsorbed state, an intermediate to the hydrogen absorption here. Okay, again, there's a change, a shift in potential. And again, it would be very, very unlikely, after this is a weakly adsorbed hydrogen, that's a strongly adsorbed hydrogen. But again, it would be unlikely to claim this as an intermediate for this one, since it's again thermodynamically impossible. So, and missing clear evidence for the adsorbed state as a precursor for the absorbed state, diffusion of hydrogen into palladium. I claim, and my conclusion is, that there is a direct diffusion of hydrogen into the palladium metal lattice without passing through any adsorbed state. That's what I think. And with the addition of crystal violet or platinum or other poisons, you remove your hydrogen layer and you get a significantly enhanced kinetic. You rapidly insert your hydrogen into your palladium bulk. Well, I want you to understand that, because that's a specific project, and I want to put it as general as possible. So far, people assumed to have the hydrogen layer blocking the surface. No, not blocking. So far, people assumed that hydrogen layer covering the metal surface is a promoter for the absorption and diffusion of hydrogen into the metal lattice. But actually, that's not wrong. That's not right. It's wrong. Hydrogen is blocking the metal surface, so that diffusion cannot occur rapidly into the metal lattice, palladium metal lattice. Diffusion of hydrogen into the metal lattice is a direct process. And once hydrogen is covering the surface, you will not get a rapid diffusion, insertion. While this could only be achieved once you poison the surface. You poison the surface, you remove your hydrogen layer, and you get a right enhancement. Okay, so we could only figure this out, the whole process, with the use of nanotechnology, with the use of a nanostructured palladium film. In '89, Pons and Fleischmann, they weren't able to do this because nanotechnology were not in '89. Right. But maybe in '89, maybe in doing a stupid mistake, maybe they removed somehow in carrying out the experiments using a palladium rod, maybe they removed somehow the hydrogen layer blocking the surface and carried out having a right insertion of their deuterium into the palladium rod, and the experiment worked. Maybe there was something true about that. Maybe. Maybe the chemically assisted nuclear reaction worked. Maybe there is something true about that. And maybe this is the approach. But maybe I'm sure there are, and there's a big if that worked, then maybe there are many, many other factors to be considered. That's all. Okay, thank you. Okay, that's now the next one.
We have
by doing that with acetylene.
Sniffing acetylene.
and how do you feel now?
Hydrated.
Very good.
There's a building over there with a big padlock on it that has some stuff inside that I want to
Yeah, just cut that off.
Yeah, you can go ahead and hold this. I mean, it's not going to heat up. It does get. Oh yeah, there we go. It does get bright enough that I like to use goggles, but well, here, hold this for one hand for a second. Oh, yeah, actually, I do have some balloons. Anybody want a balloon? See. Oh yeah, I'll put a hole through that.
Ooh, all right.
Let's see.
Wow, it really does put a lot of water on it.
Yeah, see those? See that water that goes on there? This one is not good to have bifocals.
So it's tipsy at that.
This when I bought my torch, I think it's like an aught tip or something. The guys that are here that do a lot of welding, they can come look at this and tell me what size tip that is. Oh, it'll just get to a point where, even though I don't have oxygen, which you still need to cut, I should be able to blow a hole through this.
So you can use that underwater also?
I've been told yes. I have not done that. So if you were cutting, it's awful close. It's awful close to.
Smell the metal.
Am I through? Yeah. Okay. Yeah. Like I say, with bifocals and those, I can't get my head. It's got a little impurities now, that's kind of jumped back off of there. We'll turn that off, and
Burning clean.
and there's probably a little.
Yeah.
But remember, it doesn't weld; it only cuts steel.
Yeah, yeah,
Yeah, you can smell.
that's true. If I had extra oxygen, man, I just cut right through that. You
Yeah,
know.
but you can't weld with it.
No,
You can't weld steel.
you can't weld
You
steel.
can only cut it.
And the problem is the extra oxygen in that flame that makes it oxidize so well and heat up so well causes it not to weld iron.
Right.
But if you have dissimilar metals, you know, the nature of the flame will cause it to, you know, reach its melting point very fast.
You couldn't weld stainless with it?
You can puddle weld stainless, but you have that oxidation factor in there.
Oh, so
Tom here's got one. He might be able to shed a little light on some of this too.
I'll be happy to. In fact, I used to work with George Wiseman, and I put them. I helped put these machines together. But this is Larry's show, so I'll let Larry.
Well, you know, I'm learning too. So I've never worked and put a machine together, you know, and I found out here at the conference that Tom did. So anyway, it's when it starts.
But what was interesting about the red flame after you took it off the iron, it stayed red. You know why it was staying red?
I do not.
Because the iron particles was trapped in the implosion of the flame.
Okay, that makes sense to me.
When you cleaned it up, it was no longer there.
Well, you have to turn
Yeah.
it off to
Any-
get rid of the
See,
iron
yeah,
particles that was entrapped.
This
in
is the
flame.
knot. This is a knot tip. So
But-
I mean, it's real small.
But like if it's true implosion, as claimed,
Yeah.
it sucked
It's-
up
it's-
iron particles and kept it in the flame.
Okay. I know, like when we slide it again here, you know, well, some of that is going to be
It's been blue before you started.
right, but some of that,
It's got to burn off.
yeah, it's got to burn off, but well, it's coming off that tip. I may have got a little particle, you know, right there in the tip, and so. See, now I'm turning the gas on faster and faster here.
It'll take a while if the tip doesn't heat up in a free style like that.
Yeah, well, what it was a pop off.
Right.
Yeah.
But I'm saying just holding it is not necessarily going to clean it out.
True.
If it doesn't get hot.
But now, see, it was hot when I had the back burner, you know, but now I can hold the tip again. But now, if I heard that there are tips that have the orifice recessed, then I think this would get hot.
Then it would get a self-clean. What I'm saying is you're going to have a while waiting for that to self-clean because it doesn't get hot enough. Larry, have you had any luck spreading the flame out into a broader flame and trying effects with not just a pinpoint laser but a broad wide flame?
The closest I've done is when I have my cutting torch tip on, and it's got, you know, like it's got a broader flame then because it's got more gas coming out. But that's the only thing I've done other than, you know, I haven't went out and bought a bunch of tips. I've been in the construction with mostly lumber, and so the metal stuff is new. But like I say, we can, those that want a souvenir of, oh, he wants me to he wants me to do 2 nickels here. Okay.
I have a bunch of dimes.
I'm going to do a quarter.
Yeah, I got kind
I should have more gas to go through too.
Folks, you're seeing water burn. This is just. No water there. Water in the tank.
There, I'm through both of them now. Put them on the ground, don't touch them.
Are you experienced enough that you could like weld 2 of them together just on one edge?
What I have done, I had a part of my baler that broke the other day, and my father-in-law, I told him what I was going to do. I told him, well, it's cast iron. I said, well, let me just take it down to my Brown's gas machine and I'll just puddle it together. Didn't have a rod or anything. And he'd go, yeah, sure. But I took it down there and I puddle welded the cast iron part that was bad, and my part held, and his part didn't. And he just he's 80 years old, and he just he couldn't believe it. But my little cast iron puddle job without any added rod held when his didn't.
Did you have to preheat the cast iron?
I heated it all up and puddle welded it, and then I thought, oh no, I was losing material, and thought it wasn't going to work myself. But we got it on and it worked fine. I had enough of a weld, that it worked. Okay, let's see if I can get this thing to work. No, I'll go back to the tried and true.
Just a sparker?
Yeah. That sparker is from Arizona Hydrogen sent it to me, and they're ones that make small machines with the transformer technology for jewelers and dentists and that sort of thing. Hey, we're back to almost.
There you go.
Color of flames changed.
See, when you hear that sound, that kind of what it is, I've got droplets of water in my hose, and yeah, because well, when the gas goes back to water, you get a little water in the hose there. Now, I found that.
Okay. I am Mark Sorption. I'm a representative of Dynalife International, which handles Dynaloop product, which is an oil additive. But it's more than an oil additive, it's a metal conditioner, because the micro pores in the metal are fine enough when magnified that the molecules in Dynaloop will flow into those micropores and treat the metal. And therefore, because it does that, it eliminates this bearing which has been a little bit too hot, and the regular oil has moved away and destroyed the bearing. This is a piston that's had the same thing happen. When the oil gets hot, it moves away and leaves a dry spot, and this was just about destroyed because the oil broke down. The Dynaloop goes to 1200 degrees temperature, and therefore this would have never happened. This would have never happened, and the vehicles would have saved thousands of dollars in repairs because of the Dynaloop being in the oil. This is a bearing out of a transmission. When the oil gets too hot, the plastic carriage that holds this melts together and stops the oil from circulating in the part of the transmission and destroys a $1,600 transmission because the oil gets too hot. Dynaloop will make transmissions, engines run about 25 degrees cooler. It withstands up to 1200 degrees temperature and is less expensive than their average products on the market today. This is the oil additive, what I'm talking about. It's used in any place you take oil. 4-cycle, 2-cycle, transmissions, differentials, automatic transmission, power steering, even can be added a little bit to a air conditioning unit. Diesel. The phone number of the company is 435-673-5406. It's in Santa Clara, Utah. Mike Eager is the CEO of the company. He can be attained at that phone number just about any time.
Do you have anything else you'd like to add about the product or its uses?
The product can be purchased directly from the manufacturer, leaving out retailers, wholesalers, and can be shipped to any place in the world from right out of Santa Clara, Utah. And it's less expensive than your better grade additives that you find in the markets.
Okay. Thank you.
You bet. Thank you.
My name is Bruce Meeland. I'm editor and publisher of Electrifying Times. It's a magazine on electric, hybrid, and fuel cell vehicles. We cover mainly transportation technology revolutions, but we also cover periodically technology on free energy, cold fusion, whatever. We've been attending these type conferences for over 10 years. We were attending the conferences in Colorado Springs when the Tesla Society was going. And so we've known Steve for a long time, and we do a lot of networking with each other. We advertise this conference in our latest edition of Electrifying Times. So basically it's state-of-the-art, mainly transportation. Right here we did a feature article on a hybrid snowmobile that's coming out to be prototyped in Yellowstone National Park. The company right here in Salt Lake City is doing the work on this project. So, like I said, we cover a lot of broad subjects, but right now the big thing is fuel efficiency in cars because of high gas prices and more revolutionary ways of generating electricity.
You have a website or a phone number?
Yeah, electrifyingtimes.com is our website, and we publish mainly most of our information on our website, and we publish maybe 2 times a year.
Thank you.
Hey, thank you. Yeah.
Hello, I'm Paul Pantone with GEET Technology. I am the inventor of the process. Over the last 25 years, we have developed a system to deliver fuel to an engine, which can give you anywhere from a 70% increase in mileage all the way up to 5 times the mileage, which has been reported throughout Europe. This system replaces approximately 2 feet of your exhaust pipe. Inside these 2 rods, which go completely through the exhaust pipe, we have rods. These little rods slip inside. As vapor is made and fed through there, it is accelerated. During the heat exchange process, an atomic breakdown occurs. The transmutation changes gasoline, crude oil, paint thinner, cleaning solvents into good, usable hydrogen. This process allows you to reduce emissions by about 90%. This is the intake that goes with it. It has 3 holes, and this one plate is not cut on the bottom. There's no moving parts, and you cut this to fit the top intake of your engine. This replaces the dual or 4-barrel carburetor you currently have with a lot of parts. The fuel delivery system in most cars is going to be fuel injected. Whether you have a carburetor now or not doesn't matter. The fuel injectors fit into these 2 holes, mixed with a small amount of fresh air, controlled by electronics which are hooked to your gas pedal. You can now control the amount of pulsing and the speed of the pulse to the engine. So instead of needing 8 injectors, you only need 2 injectors for a V8. All of this is housed inside an air filter with a cover over the air filter, like this. So everything is concealed. All the air going to the engine is going through the GEET reactor or a filtered process. While we were doing this, we made over 190 new discoveries in science, which we have now charted out, which will help other scientists to understand what they're doing with their inventions. Different universities around the world have contributed by testing our technology and sending their results back to us. Florida State said we were pulling electrons in. In Germany, they had other discoveries, but we have managed now to chart all this in. The next thing you're going to see is the 350 Chevy, which is out in the parking lot that we just retrofit and drove down here, and it's out in the parking lot. To reach us, you get a hold.
Got it? All right. This is a fully GEETed Chevy engine, which means that it runs on GEET gas, which we believe is mostly hydrogen. Underneath the truck, on the exhaust pipe, is the fuel processor. It actually turns gasoline, which we have being vaporized right here by 2 fuel injectors. It's vaporized here. The vapor is pulled down through some copper tubing to the fuel processor below, where it's converted to GEET gas, which is mostly hydrogen gas. That gas is then brought back up to the engine through these copper pipes on this side. It's mixed with a little fresh air here through this valve here, where it's combusted in the engine. The exhaust from the engine then goes through the processor and out the back of the truck and is used in the process to convert it into hydrogen, or GEET gas as we like to call it. Any other questions?
The other car?
You want to explain it?
Okay, I won't have it running, then you won't have the noise.
Yeah, you just need that mic on.
This car is mostly for demonstration to show that you can have a dual fuel. These valves here, as the gas comes out of the tank, are brought up to these two valves. Now from here I can run it back to the engine, or I can run it into the plasma system. It was already explained on that truck how that works. I won't go through that, but the reactor's down underneath, comes from this down there and back up this big hose and then goes into the engine. But the convenience of having these valves here is that while we're been experimenting and working, we can always have a car that we can drive and work on it and have it half torn down, and with our plasma units, just switch it back over and go back home. And all we need is the electronics here to control the fuel and the air mixture, and then this would be a complete unit.
You don't have to take it off.
Paul's contact info?
Yeah, like his phone number, his website or something.
Okay, you give them all up.
You don't have to take it off. You can just stand right there.
I'll just.
Just read it, or?
Yeah, just read it off the card.
Okay. You can contact GEET by going to www.geet.com. Email us at info@geet.com, or you can call Paul Pantone.
I'm Tom Vallone, Dr. Tom Vallone, the president of Integrity Research Institute. It's a nonprofit organization located in Washington, D.C. that's dedicated to energy research and education. We are established interest also in scientific integrity, and we've mostly concentrated on the sciences that deal with new emerging science of energy and also propulsion. Our latest catalog with lots of different publications, and also this year we've introduced some products that are also available. We have an interest now in zero-point energy. For example, the presentation I gave at this conference deals with zero-point energy in the future. And zero-point energy is the basis of all the universe's activities, and we see that as an emerging nanotechnology science to power the nanobots that perhaps will be very prevalent in the near future. So we also have interest in bioelectromagnetics. We've developed a couple products that are electrotherapy devices that offer high voltage electron transfer that boosts the transmembrane potential and scientifically have been shown to also increase the immune system response. So there's lots of different interests that appeal to the public, and we hope that this emerging energy science will also be popular. And
Website or phone number?
Website is integrityresearchinstitute.org, and the phone number is 800-295-7674.
Oh, hi, I'm Tony Kosolovo. I have the Photon Stimulator. I developed this in 1996 and got it patented in 98. It essentially uses pulsed plasma gas, xenon in this case, to produce a full spectrum light that then is able to be used on biological systems to produce balancing of the autonomic nervous system primarily, and secondarily clearing and energizing via the connective tissue acupuncture meridian pathways. This model photon stimulator uses, as I mentioned, full spectrum light, but actually that light travels through 6 feet of optic fiber, and it comes out through the cone tip. The cone tip is removable, allowing a much larger surface to be treated, such as surface of the skin, meridians, and chakras for those who want to approach it that way. We introduce very specific color frequencies by the Dinshaw-Gadiali series of color gel slides, which match the Fraunhofer emission lines of elements that the body uses, such as calcium, oxygen, magnesium, etc. And these have simple color names attached to them, but mostly what's important is that the spectrographic fingerprinting matches a pattern or fingerprint of signals that the body has been accustomed to as it evolved with these specific elements on the surface of the planet with light reflecting off of it for an extremely long time. Currently, this device is used in research centers. It's used all over the world. It's used by surgeons in Colombia for post-surgery treatment. It's used by monks. It's used by acupuncturists in Korea, China, Japan. It's used in alternative health clinics and in medical offices. It's used by football teams, sports medicine doctors. It's used in children's hospitals. It's very effective as an adjunct tool in allowing the body to heal itself. So it doesn't actually produce or treat specific diseases or symptoms. It puts the body into the parasympathetic part of the nervous system, as has been demonstrated on most heart rate variability monitors, Kirlian photography devices, devices from Russia like the Prognos, and it also, by doing that, puts one out of the stress mode, and only in parasympathetic does the body really have a chance to repair and heal the inner organs at the center of your body. So that is the way this works, and it's used very easily. Comes with a manual, explains the acupuncture points and health disorders and the accompanying places in the ear from where to put this cone tip. And that is now also used in the beauty industry for facials and for aesthetic enhancement, and after Botox injections and after facial surgery for helping with the healing.
Do you have a website?
The website is www.photonstimulator.com.
Thank you.
Thank you very much.
My name is Dale Pond. I've been working with the John Keeler material from the late 1880s to replicate his science, to understand his science so that we can make it practical today. This is the first design that we've attempted to build from his original machines. He originally made them as energy power sources. And he had them running, and they ran very well for him in those days. But all of his research and his materials and his books all disappeared. All of his machines, his thousands of machines have disappeared. But this particular unit is my first attempt to rediscover and rebuild that power, these machines as power sources. We've only had a moderate success with this particular unit. However, we've learned a great deal about the universal principles that govern its operation. And as time continues, we make newer versions, more improved, more powerful, and it is hoped that shortly, within the next few years, we'll have this thing operational.
Do you have an email or contact info?
SVP, our SVP website, just search my name, Dale Pond, on the web and you'll find it. It pops right up.
Great, thank you.
Hello, can you hear me okay there? Hello, my name is Alan Franker. I'm an inventor and I've invented many technologies. Today I've invented a vaporizer system that is designed to enhance the fuel economy and reduce the pollution emissions on the internal combustion engine, which has led me to various designs and applications. And I've also invented the interference test generator, which is a device that mounts the magnets and the coils stationary. We use an interruption shield in between the air gaps, and that shield causes induction in the coils as it turns. And it has a unique feature in the fact that when you load the coils, it does not slow down the rotor. And the other technology we have is a interchangeable permanent magnet dynamo, and that dynamo has interesting uses, such as we can tailor the volts and amps depending on how we mount the coils and add the coils in parallel or series. And it'll give us the ability to produce 3-phase AC power, single-phase AC power, or even up to 5-phase AC power and or DC simultaneously coming out of the machine at the same time just by cranking the rotor. And that eliminates us having to buy multiple different kinds of dynamos, conventional machines such as a separate 3-phase motor or a single-phase motor to fulfill the same need. We can get all those kinds of different phases of current out of the same machine. The other technology that I am presently working on is restoring and reviving the Edwin Gray's EMA motor impulse technology. And when we complete the system, our goal is to revive it and bring it and let everybody know about it so that we can spread the technology around the world to do our part.
Do you have a website or contact info?
My contact info is al.f@telas.net. And if you just insert my name on the Google search engine, it will come up as, all my information will come up and you can link it from there.
How's your last name spelled?
Franceur, and the first name is ALAN. Or you can just punch in ALF Vaporizer, ALF Energy, ALF Dynamo, things like that. It'll all come up. Not a problem, and thank you.
Hi, my name is Joshua Korn, and I'm with FutureTechToday.com. We do a lot with alternative health technologies, including a lot of research along the lines of Royal Rife and George Lakhovsky, a lot of historical people in the electromedical vein, electromedical research, we prefer to call it. Really interesting stuff, and we have a DVD about the story of Royal Rife and his microscope, which he used to cure cancer along with electronic frequencies. And it goes into a lot of the details about the specific frequencies that he was using and the way we can use today's technology to try to replicate what he was doing back in the 30s and 40s. And I'm from Eugene, Oregon, and like to travel around and help teach people about these historical technologies. Here we have a few different instruments. This is just a couple things that we carry. This is a frequency generator that's based on a lot of research that we did with Royal Rife. We can't really sell it as quote unquote a Rife generator because it's actually illegal to do so. But we've done a lot of work with back engineering some of the original Rife instruments, and what this instrument does is it has a real wide range of frequencies. It goes all the way up to 18 megahertz actually. It says 12 megahertz on here, but actually in dual frequency mode, which means it's doing more than one frequency at a time, it'll go up to 18 megahertz. And we did that because we found in some of the research that Rife was actually using some frequencies up in the range of 17 megahertz. And this instrument will hit that frequency very precisely, and as well as many others. It is a research instrument, but it's very versatile. It does an RF modulation as well as a straight audio frequency, which is some of the different ways people are using them. And I could go into a lot of details about it, but if y'all need more information, we have an ebook that we give away for free. If you email us at info@futuretechtoday.com and ask for it, we'll email you. And we also get into pulse magnetic field technologies, which have been through a lot of research in Europe. We work with a few different instruments along this realm, which this is one of them. This one is designed specifically for stress reduction and relaxation, and it's got 5 different settings, which are fairly basic settings, real easy to use, and what it does is it pulses very specific frequencies of energy into coils that are inside this pad, as well as a full body pad that you can lie on or direct to specific areas of the body, and help relax and relieve stress, let the body heal itself. And we have another instrument from Germany, which actually has about 20 years of clinical research behind it with medical doctors, and any medical doctors that would like to have more information can also email at the same email address, info@futuretechtoday.com, and we'll get you some detailed research studies and help you get involved in the research, hopefully. Thank you as well.
Hello, my name's Dr. Sonny Ward, and I'm at the 2004 TeslaTech conference in Salt Lake City. I've been here to accomplish and prove Tesla and also Pons and Fleischmann's cold fusion. This is a standard inverter. This is a big electric drill. You can plug this in. There's no power coming off the grid on this. It will power it. We don't want to eat up the chair, but anyway. Well, I guess I got to turn it on. I'm sorry. Got to turn it on here. Yeah, there we go. I didn't have it turned on. There we go. There we go. And it can power all these appliances. It's not hooked into the wall, has no power input. That's what we're attempting to show here. We demonstrated it, and you can be off the grid as I am. I haven't paid a power bill in 15 years, and we're hoping to have another good conference next year. Thank you very much.
Thank you. Do you have any contact info? Or?
If you want to contact us, I guess the best thing, we don't have email, and what we have is the fact that you can call me at 208-662-5268. Mornings is best for more information.
Great, thank you.
You bet.
Well, we're here at the Extraordinary Technology Conference, and I brought with me some interesting things because I think that healing is a do-it-yourself job a lot of times, and I brought an acupuncture light that a person can work on the meridians. They can work on acupuncture points of their body themselves. It does 8 different modes, all the primary colors, and people love it. They experience a relief if they have pain or if they've been in pain. So acupuncture with light is a thing of the new future that we're all going into right now, technology-wise. And it's healing with light has been around for a long time. Then I brought with me the chi balls, the copper balls that you can use to increase your electronic body. And it has quite a grounding, amplifying effect of your electronic body. So people like the solid copper 100% balls, the chi balls. And I also brought with me a device that does electro stimulation. Electro stim can be used to alleviate pain, to balance the right brain, left brain hemispheres. It can be used for massage. It can be used for raising the kundalini up the spine. It helps increase your kundalini energy, balance left and right brain hemispheres. And along with that, the world's #1 selling liquid botanical, Bimetol Botanical. So it's been fun being here, and I've really enjoyed myself. So.
Do you have a website or contact info?
Yes, people can contact me at auroralight@earthlink.net. Thank you.
I'm Dr. Patrick Estes. I'm a naturopath from San Francisco, California. What I've done is developed an energized water called Nectar of the Universe. What the water does is raise your body's vibrations, which puts all your energy fields in a total balance. When your energy fields are in total balance, it creates the body's natural ability for healing itself. What we've done is a computerized program from BioMeridian where we can measure your energy fields and show you before you drink the water how you're out of balance, and show after you drink the water how it brings you into complete balance. If you drink 1 liter a day of my energized water in 90 days, it'll eliminate most, if not all, of your toxicity.
Great, thank you. Do you have a contact info or a website or anything?
Yes. You can reach me look at me on my website, www.nectaroftheuniverse.com.
Great, thank you.
Thank you.